Hello, my dear students. Can we solve the questions? Total number of atoms in 18 AMU of H2O. We know that 18 grams of H2O contains H2O is a combination of 3 atoms, 3 into Avogadro number of atoms, 6.023 into 10 power 23 atoms. Then question is 18 AMU. 18 into 1.66 into 10 power minus 24 grams of H2O contains how many number of atoms? Cross multiply 18 into 1.66 into 10 power minus 24 into 3 into 6.023 into 10 power 23 by 18. Then you will get a 2.999 nearly equals to 3. Which of the following is correct? A does not undergoes redox reaction. A is not a redox reaction because left side or right side oxidation states remain same. So A is not a redox reaction. B is a redox reaction because 0 is converted to -1, 0 oxidation state is converted to +1. So it is a redox reaction. C, oxidation state of chromium is +6. The reactant side, the product side also oxidation state of chromium is +6. So it is also not a redox reaction. A and C are not redox reactions. Position of element Z is equals to 108. Z is equals to 108. The element name is hassium. Z is equals to 108. The element is hassium. Hassium is a D block element. Belongs to which group? 1, 2, 3, 4, 5, 6, 7, 8. D block, 8th group. Element name is hassium. Select incorrect statement. 4D XY energy is equals to 4D Z square energy. Generally, energy is calculated by using the formula N plus L. 4 plus orbital L value is 2. 4 plus 2 is equals to 6. 4 plus 2 is equals to 6. So this is correct statement only. Psi 200 less than Psi 300. This 200, this is represent Psi n L n. First number represents principal quantum number. Second number represents azimuthal quantum number. Third number represents magnetic quantum number. Energy is calculated by using the n plus L value. 2 plus 0 is equals to 2. 3 plus 0 is equals to 3. 2 is less than 3. Number of angular nodes is calculated by using the L value. P orbital L value is equals to 1. Here also P orbital L value is equals to 1. So number of angular nodes 2px is equals to 3px. But here what is given? 2px less than 3px is given now. So this is incorrect statement. In BRF3 molecule, the lone pair occupy equatorial positions to minimize lone pair repulsions and lone pair bond pair repulsions according to VSC-PR theory. BF3 molecule has zero dipole moment. Correct. BF bonds are polar in nature. Yes, this is also correct. Generally, for polar molecules, mu value not equals to 0. Non-polar molecules, mu value is equals to 0. BF3 mu value 0, but BF3 is a polar molecule. In BF3, BF bonds are polar. Why? Fluorine is more electronegative element. That's the reason BF bonds in BF3 molecules are polar. A is true, R is true, R is the not correct explanation of A. Bond energies of H2, N2 and NH bonds respectively are X, Y, Z kilocalorie per mole. Then enthalpy of formation of NH3. See, bond energy of H2 is given, started with H2. H2 bond energy is X. So 3X. N2 bond energy is Y. H bond energy 2 into 3 into NH. Bond energy is Z. In NH3 molecule, 3 NH bonds are present. That's the reason 2 moles into 3 NH bonds. Bond energies are given. So delta H is equals to bond energy of reactants minus bond energy of products. Y plus 3X minus 6Z. We know that enthalpy of formation means formation of 1 mole of the product. Formation of 1 mole of the product. According to this equation, 2 moles of the products is formed. 2 moles of NH3 requires Y plus 3X minus 6Z amount of energy. Then 1 mole of NH3 requires how much energy? Cross multiply. Y plus 3X minus 6Z by 2 amount of energy. Or it can be written as Y by 2 plus 3X by 2 minus 3Z. Fourth option is correct option. The correct order of strength of hydrogen bond in the following compound. The strength of hydrogen bond is directly proportional to electronegativity of the central atom. Electronegativity order, fluorine is more electronegative element, after that oxygen, after that nitrogen, after that chlorine, after that sulfur, like that. So fluorine is more electronegative element. HF, H2O, H2O2. H2O forms 2 hydrogen bonds. After that H2O2, finally H2S. pH curve is valid for. pH curve is given as like this. This is look like weak acid and strong base pH curve. Remaining pH curves are also given. Please practice. Reaction is given at a certain temperature. Kp is equals to 1.44 atmosphere square. If the partial pressure of NH3 at a certain extent is 1.08 atmosphere, then reaction will proceed. So calculate QC value. We know that this is a solid, these are gases. At equilibrium, X amount of NH3, X amount of H2S is formed. That means at equilibrium, partial pressure of NH3 is equals to partial pressure of H2S is equals to, what is the value given? 1.08. Now calculate the value of Kp. Kp is equals to partial pressure of into partial pressure of H2S by, it is a solid, take it as unity 1. Partial pressure of NH3 is 1.08. Partial pressure of H2S is also 1.08. Simplify. 1.08 into 1.08. then you will get 1.1664. Sorry, this is the QC value, not KP value. QC value is equals to 1.1664. Now identify the relation between KP and QC. QC is less than KP. QC less than KP, reaction goes from left to right. Reaction goes from left to right. That means reaction moves towards forward direction. Which of the following statement is incorrect? Fourth statement is incorrect. Remaining statements are correct only. How fourth statement is incorrect? HCN is a weak acid. NaOH is a strong base. Acid base combine to give salt plus water. Salt is formed. The salt base is strong. So this is considered as a basic salt. NaCN is a basic salt. For basic salts, the pH value is greater than 7. But here what is given? pH is equals to 7 is given. That's the reason that statement is not correct. Assertion: enthalpy of formation of HF is the most exothermic among its group hydra acids. Correct. Why? Because fluorine is the more electronegative element. Reason: order of bond enthalpy F2 greater than Cl2 greater than Br2 greater than I2. This is wrong. What is the bond enthalpy order? Cl2 greater than Br2 greater than F2 greater than I2. So based on this, A is true, R is false. The correct order of first ionization potential of boron family is correct order of first ionization potential. According to the table, the correct order of first ionization potential is boron greater than aluminium, less than gallium, greater than indium, less than thallium. So fourth option is correct option. Which one is strongest oxidizing agent? Oxidizing agent means reduction process takes place. Correct answer is PbO2. Why? Due to inert pair electron effect, Pb2 plus is more stable than Pb plus 4. Here, lead oxidation state is Pb plus 4. Pb plus 4 is unstable. Pb2 plus is more stable. Pb plus 4 is converted to Pb2 plus. When it is converted to Pb2 plus, if it gains electrons, gain of electron is called as reduction and it acts as a strong oxidizing agent. 0.56 grams of organic compound was Jaldalyzed. That means Jaldal's method. Jaldal's method, the percentage of nitrogen is calculated by using the formula. Percentage of nitrogen is equals to 14 by 1000 into normality into volume, excess of acid divides with weight of organic compound into 100. Now normality into volume calculate. 50 into 1 is equals to 50. Normality into volume 60 into 0.5, that is equals to 30. So acid number of milli equivalents of acid is equals to 50. Acid number of milli equivalents is equals to 50. Base number of milli equivalents is equals to 30. This 50 is also written as 30 plus 20. So 30 milli equivalents of acid combines with 30 milli equivalents of base. Remaining, how many milli equivalents of acid is excess? 20 milli equivalents of acid is required. Acid is excess. So 14 by 1000 into normality into volume. How much is excess? 20 by weight of organic compound 0.56 into 100. 0, 0, 0, 0, 0, 0 cancel. 28 divides with 0.56. Then you will get 50 answer. Percentage of nitrogen. The IUPAC name of the compound. Consider the long chain. This is the carboxylic acid, high priority group 1, 2, 3, 4. Third position hydroxy group is present. Second position double bond is present, that is methylidene. 3 hydroxy 2 methylidene. This is nothing but double bond CH2. Double bond CH2 is called as methylidene. Butanoic acid. One is the most stable carbocation. First case, resonance is possible. Oxygen able to donate pair of electrons. Second case also resonance is possible. Third case, nitrogen is present here, carbocation is present here. Resonance is not possible. Fourth case also resonance is not possible. We know that stability of carbocation, many factors are there. The stability of carbocation directly proportional to electron donating group, directly proportional to number of alpha hydrogens, even directly proportional to resonance also. So resonance predominates remaining factors. So third option or fourth option ruled out. Now both cases resonance is possible. We know that oxygen is more electronegative element compared with nitrogen. More electronegative elements not donates pair of electrons easily. But less electronegative elements donates pair of electrons easily. So the correct option is second option. Which of the following alkane will be formed in high yield by Wurtz reaction? Wurtz reaction. In case of Wurtz reaction, alkyl halides, the alkyl halides must be same type of alkyl halides. Consider same type of alkyl halides. So based on that, first option is correct option because ring number remains same here. So consider as same type of alkyl halide. Here ring number is different. Different type of alkyl halide. Ruled out. Alcohol reacts with H plus delta. That means nothing but dehydration process takes place. Alcohol adjacent carbon is quaternary carbon, directly attached to 4 other carbons. So that is quaternary carbon. So first of all, remove OH minus ions. If you can remove OH minus ions, then you will get P, CH, positive charge, CH3. Now, this is 2-degree carbocation. Adjacent carbon is quaternary carbon. That's the reason ring expansion takes place. Ring expansion. Break the bond between carbon and carbon. Then one carbon gets positive charge, another carbon gets negative charge. Now, attractive forces are developed between newly formed negative charge and already existing positive charge. Then, so here in this ring, how many carbon atoms are present? Total number of carbons 1, 2, 3, 4, 5, 6. It can be written as a regular 6-membered ring. like this. So is present pH group adjacent CH. This is carbocation positive charge. CH3 positive CH3. Now remove hydrogen atom. Already we removed OH minus ion. Now you can remove hydrogen atom. Remove hydrogen atom from beta carbon. Yes, this is the beta carbon. Contains less number of hydrogens, so remove because HF product is the major product. pH CH3. Based on that, fourth option is correct option. Compound X reacts with KMnO4H plus. Then it gives A plus B plus C. A reacts with zinc amalgam concentrated HCl. Then it gives alkane. That means A is a carbonyl compound. Carbonyl compounds reacts with zinc amalgam concentrated HCl. Then it gives alkane. This is a reduction process. Now identify. Identify. Fourth one is correct option. How? How fourth one is correct? Take the fourth compound. Fourth compound here. C double bond CH2 group is present. Reaction with KMnO4. If double bond CH2 group is reacts with KMnO4, then CO2 plus H2O it liberates. So double bond CH2 group liberates CO2 plus H2O. Now here 1, 2, 3, 4. That means this is double bond Cr2. Because here one carbon, here one carbon. Alkyl group, alkyl group. Double bond Cr2 group is converted to ketone. If double bond CHR group, the double bond CHR group is converted to carboxylic acid. So it is converted to ketone. Double bond O plus CO2 plus H2O. Yes. Now it reacts with zinc amalgam. Then carbonyl group is converted to alkane. Zinc amalgam concentrated HCl. Alkane is formed. This is Clemmensen reduction. CO2, B is CO2. CO2 reacts with CaOH twice. CaCO3 is formed. H2O reacts with CuSO4. C is H2O. Based on that, correct option is fourth option. Correct statement regarding 1 and 2 is, take the first structure. In the first structure, resonance is possible. Due to resonance between carbon and nitrogen, double bond is formed. In the second structure, resonance is possible? No, because lone pair pi bonds, lone pair single bond pi bonds are not present alternatively, so resonance is not possible. So between carbon and nitrogen, single bond is present. Bond order value increases, then bond length value is decreases. So Cn bond length in 2 is greater than Cn bond length in 1. Which of the following boiling point will not be increased? Boiling point will not be increased. Which of the following boiling point will not be increased? Third one, addition of Ki in 1 molar HgI2. What happened? HgI2 plus Ki. Then it is converted to K2HgI4. Initially, HgI2 is reacts with Ki, then it gives K2HgI4. Total number of moles of particles 3 moles converted to 1 mole of the compound. That's the reason boiling point will not be increased. So number of moles of particles decreases due to formation of a complex compound, which will increase the voltage of the cell. Which will increase the voltage of the cell. According to the given equation, write the Nernst equation. So first case, I assumed the concentration of Sn is 10, concentration of Ag plus is 1. So E naught cell minus 0.0591 by N log of Sn concentration is 10, Ag plus ion concentration is 1. Log 10 by 1 is equals to 1. Here E naught cell minus 0.0591 by N. So voltage of the cell is decreases. So case 1 is wrong. Case 2, I considered Sn concentration 1, Ag concentration 10. I increases the concentration of Ag plus ions. Then E cell is equals to E naught cell minus 0.0591 by N log of Sn concentration 1, Ag plus ions concentration 10 whole square. Then E cell is equals to E naught cell minus 0.0591 by N log of 10 power minus 2. Log of 10 power minus 2 is also written as E cell is equals to E naught cell minus 0.0591 by N minus 2 log 10. Minus into minus plus. E cell is equals to E naught cell plus 0.0591 by N 2 log 10. Now here voltage of the cell is increases. So increase the concentration of Ag plus ions. Third option is correct option. Osmosis, solvent moves from higher vapor pressure region to lower vapor pressure region. Direct question this is. Threshold energy of a chemical reaction depends upon. Threshold energies depends upon nature of the reactant species. Not only nature of reactant species, it also depends upon, here that option is not given. Threshold energies also depends upon presence of a catalyst. Also, acidified water is electrolyzed by 2 Faraday's charge. The total volume of the gas produced at STP is. This is the formation of H2O reaction. If we can pass 1 Faraday of current, 1 mole of H2, half mole of O2 is liberated. 1 mole of H2 volume is 22.4 liters. Half mole of O2 volume is 11.2 liters. Add 22.4 plus 11.2 is equals to 33.6 liters. Sorry. If we can pass 1 Faraday of current through a substance, then 1 by k moles of the substance is deposited. If we can pass 1 Faraday of current, 1 by k moles. Okay. Now, H2 releases H plus ion. So, 1 by 2 moles of H2, then charge is O2 minus 1 by 4 moles of O2. 1 by 2 moles value, 1 mole 22.4 liters, 1 by 2 moles 11.2 liters. 1 by 4 moles, 5.6 liters. Total value 16.8 liters. If we can pass 1 Faraday of current, 16.8 liters of the substance, 16.8 liters of the gas is liberated. Instead of 1 Faraday, suppose if we can pass 2 Faradays of current, 2 into 16.8, that is equals to 33.6 liters. Fourth option is correct option. The incorrect order against the indicated property is, incorrect order is, boiling point order is incorrect. Which boiling point value is more? BiH3 boiling point value is very high. But here given NH3 boiling point is given high. So this is incorrect order. Statement 1, cerium plus 4 is a good oxidizing agent. Correct. Because common oxidation state of lanthanides is plus 3. Here plus 4 gain 1 electron, then it is converted to plus 3. That's the reason it acts as good oxidizing agent. Eu2 plus acts as good oxidizing agent. Wrong. Eu2 plus loses 1 electron, then it is converted to plus 3. Eu2 plus is acts as a good reducing agent. So statement 1 is correct, but statement 2 is incorrect. First option. 87.5% of a first order reaction is completed in 45 minutes. The time in which 99.9% of the reaction will be completed is, first order reaction T 99.9% and T 87.5% relation is, T 99.9% is equals to 10 by 3 into T 87.5%. What is the value given? 45. Simplify. 450 by 3. 450 by 3 value 150. Correct answer is first option. Sorry, third option. Which of the following pairs contains only tetrahedral complexes? According to this hint, ZnCl4 2 minus is tetrahedral. MnCl4 2 minus is also tetrahedral. Correct option is first. Pyrolusite, when fused with KOH and oxidized with air, it forms pyrolusite. Formula of pyrolusite is MnO2. Pyrolusite reacts with KOH and O2, then it gives K2MnO4. It is given the compound reacts with zinc amalgam concentrated HCl. What is the product? Yes, carbonyl compounds reacts with zinc amalgam, then reduction takes place and it gives alkane. CHO group is converted to CH3. Now this is alcohols. Alcohols are reacts with concentrated HCl, then nucleophilic substitution takes place and it gives in the place of OH. OH place is replaced with chlorine. Nucleophilic substitution takes place. OH group is replaced by chlorine atom. Third option is correct option. Benzaldehyde does not give positive test with. This is benzaldehyde structure. Benzaldehyde is a aromatic aldehyde. Yes. Tollens reagent gives positive test. Fahlen's reagent gives negative test. Only aliphatic aldehydes gives. 2,4 DNP. 2,4 DNP gives positive test. What is the use of 2,4 DNP? 2,4 DNP. Sometimes this is also given as Brady's reagent. Brady's reagent. Yes, 2,4 DNP is reacts with a carbonyl group. So only B is only B. Which of the following is most reactive towards electrophilic substitutions? Most reactive towards electrophilic substitutions. Aromatic compounds are most reactive. Aromatic, here which functional group is present? Amine functional group is present. Aromatic amines are most reactive first of all. Now check it. This is not directly attached to ring. This is aliphatic amine, ruled out. Nitrogen atom is not directly attached to ring. So this is aliphatic amine. This is also ruled out. Yes, this is nitrogen atom directly attached to a ring. This is aromatic. This is also aromatic. Which is most reactive? First one is most reactive. Second one is least reactive. Second one is acetanilide. Carbonyl group. Nitrogen adjacent a strong electron withdrawing group is present. That's the reason it is less reactive towards electrophilic substitution compared with first one. In maltose, the two glucose molecules are linked by C1, C4, both are alpha units. First option is correct option. Yes. Acetylene reacts with HgSO4, H2SO4. What we know, HgSO4, H2SO4, acidic hydrolysis. Alkynes are undergoes acidic hydrolysis. Follows Markovnikov's rule. Add hydrogen atom one side, OH group another side. This is vinyl alcohol. Vinyl alcohols are participate in tautomerism process. Participate in tautomerism process and it gives aldehyde. How? Pi bond is moves towards oxygen side and proton is moves towards unsaturated carbon which contains more number of hydrogens. Then it gives CH3CHO. This is A. CH3CHO. Carbonyl group is present. Carbonyl compounds are more reactive towards nucleophilic addition reactions. Now it reacts with Grignard reagent CH3MgBr. CH3MgBr break the bond. Alkyl group gets negative charge. Magnesium MgBr gets positive charge. So negatively charged alkyl group is moves towards carbon side because it is a nucleophile. Nucleophilic addition takes place. Immediately pi bond is delocalized. So oxygen gets negative charge. Then it gives a adduct. The adduct is CH3C, CH3, HO, MgBr. Which on further hydrolysis? Which on further hydrolysis H plus OH minus. Oxygen gets negative charge. MgBr gets positive charge. Then it gives CH3, CHOH, CH3. CH3, CHOH, CH3. Now, this is B. It is reacts with a red phosphorus bromine. OH group is replaced with bromine atom. Then it gives CH3CHBr, CH3. What is the final product? The final product is first one. A new carbon-carbon bond formation is possible in Reimer-Tiemann reaction. Phenol reacts with chloroform in the presence of KOH. Then it gives salicylaldehyde. Here between carbon-carbon a new bond is formed. An equimolar mixture of alkyl bromide and ammonia gives B, which on treatment with NaNO2 and HCl gives C. Compound C on oxidation followed by decarboxylation gives ethane. Decarboxylation. We know that in decarboxylation process, product contains one carbon atom less compared with reactant. So reactant, product is ethane, reactant is prop. Prop combination is the reactant. Now first option is ruled out. Here two carbon atoms are present. Take the second option. CH3CH2 CH2Br reacts with NH3. We know that alkyl halides are reacts with ammonia, then it gives 1 degree amine CH3CH2 CH2NH2. 1 degree amine. This is 1 degree aliphatic amine reacts with NaNO2 plus HCl. Reacts with NaNO2 plus HCl. If 1 degree aliphatic amines reacts with NaNO2 plus HCl, then it gives alcohols. If it is aromatic amines reacts with NaNO2 plus HCl, then it gives BDC. But this is aliphatic amine, that's the reason alcohols are formed. Now alcohols undergoes oxidation. Alcohols are undergoes oxidation, then it gives carboxylic acid CH3CH2 COOH. Yes, propanoic acid. It undergoes decarboxylation. Decarboxylation reaction with NaOH plus CaO. Then it gives product contains 1 carbon atom less compared with reactant. So it gives ethane. So correct option is second option is correct option. Identify why. Okay. Phenol reacts with C6H5COCl. It is in the form of RCOCl. Phenol. RCOCl is acid chloride. This is phenol. Phenol reacts with acid chloride. Which reaction takes place? This is esterification process. Esterification. Esterification, then it gives O. C double bond O, C6H5. Now undergoes nitration. Undergoes nitration, reaction with HNO3 plus H2SO4. What is the electrophile? The electrophile is NO2 plus. Electrophile is NO2 plus. Oxygen acts as strong electron donating group. Carbonyl group is acts as electron withdrawing group. With respect to electron donating group, NO2 group is substituted para position. With respect to oxygen, NO2 group is at para position. Then it gives C double bond O, N. So first option is correct option. Yes. Compound reacts with Br2Fe. Halogenation takes place. CH3 group is electron donating group. Ring activator. It gives ortho and para product. Already para position is occupied with the NO2 group. So substitute bromine atom at ortho position. Now you can check with respect to NO2. Bromine is at meta position. NO2 is electron withdrawing group. So it is correct. Reacts with Sn plus HCl. Reduction process takes place. NO2 group is converted to NH2 group. CH3 Br NH2. Aromatic amine reacts with NaNO2 plus HCl. In the place of NaNO2 plus HCl, sometimes they will give HNO2 or HONO or simply nitrous acid. It is aromatic 1 degree amine. That's the reason it is converted in the form of BDC, N2 plus Cl minus CH3 Br. Reacts with water in the presence of acid. So N2Cl place diazo group is replaced by hydrogen atom. CH3 Br. This is the final product. Sorry, CH3 Br. The CH3 Br reacts with KMNO4 OH minus. Which process takes place? Side chain oxidation process takes place. Side chain oxidation irrespective of carbon chain length. CH3 group is converted to COOH group, Br. So second option is correct option. Which one of the given combination is not correct? IF5 is not correct. IF5 undergoes sp3d2 hybridization with one lone pair. Geometry is square pyramidal geometry. The uncertainty finding position and momentum of a particle is same. Delta x is equals to delta p, given condition. Okay. The uncertainty of finding its velocity, we know that delta x into delta p is equals to h by 4 pi. Given condition delta x is equals to delta p, in the place of delta x use delta p. Delta p into delta p is equals to h by 4 pi. P indicates momentum. Momentum is equals to mass into velocity. So delta p is equals to m delta v. We know that m delta v is equals to delta p. Momentum is equals to mass into velocity into m delta v is equals to h by 4 pi. So delta v square is equals to h by 4 pi m into m square, here multiplied, here divided. Delta v is equals to square root of h by 4 pi m square, or it can be written as 4 square root is 2, m square root is m square root is m, 1 by 2m square root of h by pi. Correct option, third option. KSP of a salt NiOH twice. KSP value is given as 2 into 10 power minus 15. Then molar solubility of NiOH twice in 0.01 molar NaOH is. Both cases OH minus ion is common. According to common ion effect, Ni2 plus OH minus ion concentration is taken as 0.01. 0.01 means nothing but 10 power minus 2 whole square. Then Ni2 plus is equals to 2 into 10 power minus 15 by 10 power minus 4. 2 into 10 power minus 11. Ni2 plus, or it is equals to molar solubility. Third option is correct option. Thank you.